This cosmological framework is built around a fractional 9.6-dimensional manifold. It emerged not from a physics laboratory, but from anomaly detection code written by a systems builder for 3D vector steganography. The initial problem was computational. Standard mathematics often crashes when trying to run a fluid environment through code that encounters an absolute zero. The code threw persistent null multiplier bugs. When processing an alternating digital string, like 1 plus 0 plus 1 plus 0 plus 0 plus 1, the system would fail, outputting a 0 or clearing the cache entirely. These failures trace back to a specific structure in Euclidean logic, which defines the mathematical zero as a weightless void. This digital error has a direct parallel in cosmology. Assigning no physical weight to the vacuum generates the 120 order of magnitude discrepancy currently found in vacuum energy calculations. In both the broken script and theoretical physics, the space between matter is treated as an empty coordinate grid rather than a physical entity. To stabilize the code, the creator applied a physical heuristic intervention. The algorithm's definition of nothingness was overwritten with a non-zero base limit. A probability weight of 0.111111, repeating, was injected into the vacuum state. With 0 now carrying weight, the addition string that previously crashed the system resolved correctly. This result suggests that the vacuum of space possesses a measurable viscosity. Within this framework, this weighted vacuum is called the superfluid substrate. Assigning mass to the void redefines the environment as a continuous, load-bearing liquid. The success of this algorithmic fix indicates the vacuum behaves as a fractional fluid. It provides a computational path forward in areas where integer-based models fail to account for baseline weight. To conceptualize this liquid universe, we can use the tactile mental model of the butcher's sink. Inside a literal butcher's sink, you have isolated solids, bones and scraps, surrounded by a continuous liquid medium of blood and water. Standard physics focuses on the solids, matter and galaxies, while treating the surrounding liquid as empty space. Fractal pressure cosmology inverts this. The primary universe is the continuous liquid, weighted at 0.1111, and observable matter represents the runoff. Matter in this fluid dynamic is cavitation wake. Humans, planets, and galaxies function as low-pressure voids, bubbles trapped within the dense 9.6D fluid. If matter is a bubble in a fluid, gravity is understood by measuring the pressure of the ocean rather than the bubbles floating in it. This raises the engineering problem of calculating the internal pressure of that cosmic ocean. Standard physics attempts to measure a fluidic volume using a rigid straight tape, missing the 0.4 gap created by the geodesic curve. Pulling that tape tight ignores vacuum viscosity, forcing a flat line onto a 9.6-dimensional curve, distorting the final calculation. This measurement blindness creates the need for dark matter in standard models to balance galactic scales. In this framework, dark matter is identified as the physical viscosity of the vacuum. Applying integer geometry to a fractional fluid creates discrepancies that obscure the universe's structural pressure. To calculate the fluid accurately, it must be measured from the outside boundary layer. This requires the metric tensor. It acts as a topological bounding box, calculating the internal pressure of the fluid based on the geometry of the exterior planes. The tensor maps vacuum density as it seeks equilibrium against the bubbles of matter. Applying this calculation to the universe yields a specific raw pressure value, 2,803.15. This represents the omnipush, the total structural weight of the cosmos pressing inward. While string theory posits 10 whole dimensions, this tensor relies on a fractional 9.6. This occurs through topological symmetry breaking. When higher dimensions overlap and share information, they compress. This compression is described mathematically as the Hausdorff dimension. Rather than a 10-dimensional integer bundle, the universe exists as a 9.6-dimensional fractional manifold. This leaves a 0.4-dimensional remainder, which this model identifies as a reciprocal exit path. Fractal pressure cosmology identifies this 0.4 remainder as a primary structural constant. Physically, this 0.4 remainder acts as a thermodynamic vent. This vent prevents a high-viscosity fluid universe from undergoing an infinite pressure collapse. Multiplying the raw tensor pressure by this dimensional vent calculates the thermodynamic exhaust of the system. We multiply the raw metric pressure of 2803.115 by the leakage gap of 0.4. The calculation resolves to 1121.246. In physics terms, this is the exact Hawking friction that must bleed out of the system to maintain equilibrium. This is reflected in the unified equation, which calculates the balance between the total pressure and the reciprocal equilibrium constant. The exhaust bleeds through the dimensional seams at a 3.6-degree offset. This maintains stability by accounting for the observer mass sink and the reciprocal flow. The universe uses these fractional seams to simultaneously breathe in and out, stabilizing the omnipush. By applying fluid dynamics to the 9.6-dimensional manifold, the model accounts for the missing mass attributed to dark matter. The vacuum becomes the measurable substrate through which the universe evolves,